So what we did yesterday, we went through the definitions of chemistry, the study of matter, right? What the matter is anything which has mass and occupies space. We have also discussed what are the common states of matter, solid, liquid, gas, plasma, right? Then we have also seen that each and every kind of matter is composed of what? The atoms. And we also know that there are many particles of atom. There are many particles in which the prominent ones are, the fundamentals are electron, proton, and neutron. Besides these, many other particles are there, like positron, as I told you yesterday, neutron, neutrino, antineutrino, mesons, freon, hyperons, blah, 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 so on. Number of particles are there. Broadly speaking, how many parts an atom has? Just two parts. Nucleus and extranuclear region. All the particles except electron, they reside where? In the nucleus. They live in the nucleus. Whatever the kind of the particle is, all the particles live in the nucleus except electrons. Where can we find electrons? They revolve around the nucleus in various shells, right? You know it, okay? Okay, let's continue. What are we doing? We are studying the basic definitions, right? We are studying the basic definitions and of chemistry, what the atom is, fundamental parts of an atom, electron, proton, neutron. Now we are studying about the few characteristics of these fundamental particles. Electron. So it's a part of an atom which revolves around the nucleus. It carries a force. We call that force negative charge, right? So what is the sentence here? Electrons are negatively charged. What does it mean? It means electron is possessing a kind of force that scientists call that force a negative force. Otherwise, there is no minus plus related with mathematical minus plus related with electron. It is just to mention a kind of force, right? So these are negatively charged. We can find electron around the nucleus revolving in different shells, as you can see afterwards. There are so many particles, fundamental particles. The lightest one is electrons characteristics, right? Electrons negatively charged, revolves around the nucleus. Lightest fundamental particles means among electron, proton, and neutron. Electron is the lightest one. What is the purpose? What is the use of electrons? All chemical reactions are just because of electrons. Means electrons are responsible for chemical reactions, right? And its mass is 9.1 into 10 to the power minus 31 kg, as you can see on the screen also. And what is the value of its charge? Charge means its power. It's 1.6 into 10 to the power minus 19 coulombs. Okay? Negatively charged, revolves around the nucleus. Lightest fundamental particle, mass is 9.1 into 10 to the power minus 31 kg. Charge is 1.6 into 10 to the power minus 19 coulomb. And it is responsible for the chemical reactions. Okay? Now proceed to the next. Proton. Proton, where can we find proton? As I told you, protons are present in the nucleus of an atom, right? And it is much heavier than a single electron. 1836 times heavier than an electron. And its mass is 1.672 into 10 to the power minus 27 kg, and it has the power, it has a charge. But the nature of the charge is totally opposite to that of electron. That is why scientists just call it positive. So if someone asks you what is the charge on a proton, Positive. What is charge on electron? Negative. Right? I repeat, proton is positively charged, lives inside the nucleus, right? Responsible for nuclear reactions. Its mass is 1.672 into 10 to the power minus 27 kg, and its charge is 1.6 into 10 to the power minus 19 coulomb. Means electron and proton have same charge, right? Let me admit the latecomers. And finally, the neutron. No power, no attractive power, no charge at all. That is why we call it, it's a neutral particle. It's a neutral particle. It is the heaviest, means among electron, proton, neutron is the heaviest. We can also find neutron in the same nucleus, right? It is 1837 times heavier than a neutron, than an electron. It is again used in nuclear reactions. You must have heard atomic bomb. So proton, neutrons, they are used in nuclear reactions. Let me admit the latecomers. So if I summarize what we did up till now, atom, the fundamental particle, the building block comprises of few fundamental particles: electron, proton, neutron. Electrons negative, proton positive, neutron no charge, electron lightest, neutron heaviest. They have charges. Neutron has no charge, electron revolves around the nucleus, proton, neutron lives inside the nucleus, right? Just note down the question if you have. We'll ask, we'll see in the end. Now let's proceed further. Atomic number. Most important thing. Before we proceed, let me give you an example. In any school, a student has GR number, roll number. That roll number gives some information. If the roll number changes, name of the student changes, information changes. Same is true in case of atoms. If an atom has one proton, its characteristic will be different. If an atom has two protons, its characteristic changes. Three protons change. So they are given names accordingly, right? If we have one proton, we call it hydrogen. If an atom has two protons, we call it helium. 3 protons, lithium. 4, beryllium. 5, boron. 6, carbon. 7, nitrogen. 8, oxygen. 9, fluorine. 10, neon. As the number of proton changes, name, characteristic, properties changes. So that is why number of protons has been given a specialty, a number, atomic number. So what do you mean by atomic number? Atomic number means number of protons present in the nucleus. Right? Please be on time. It creates problem. It creates disturbance. So I'm repeating, protons, number of protons, very important. It gives you the characteristic. Its number gives you the characteristic properties to an atom. Number of proton changes, the name of the atom changes. 1 proton, hydrogen. 2 protons, helium, and so on. That is why you can see on the screen. What is that screen? The number of protons present in the nucleus of an atom is called atomic number or charge number. Okay? So atoms, fundamental particles of atom, and we went through what? The atomic number. Now the next is substances. All the substances can be divided into two categories, either pure or impure. Either pure or impure. If it is impure, we call it mixture. If it is impure, we call it mixture. If it is pure, then there are two possibilities. What are those two possibilities? Either it contains only one kind of atoms, different kind of atom. Suppose it's a piece of silver. In this piece of silver, all the atoms are alike. All the atoms have same atomic number. All the atoms have same properties. All the atoms have same characteristics. Only atoms, same kind of atoms are present. We call it element. We call an element. So if a pure substance has only one kind of atoms, we call it element. What do you think? Is water an element? Correct. Water is not an element because it contains two different kinds of atoms, two different kinds of elements, hydrogen and oxygen. So what do we call such type? We call them compounds. We call them compounds. I repeat, for the latecomers, all the substances can be divided into two groups, either pure or impure. If it is impure, like soil is impure, we call it mixture. Like air, mixture, right? Blood, mixture. Or it could be pure. All of these things we will study in detail afterwards. It's just a brief revision relating with your previous studies that you already know in grade 8 and 7. You know that elements, compounds, and mixture you have studied. Okay? So pure substances are of two kinds, elements and compounds. Elements contain only one kind of element, like gold, like silver, like aluminum. Compound contains different kinds of atoms which are bonded, which are joined together differently by bonding. Okay, so this is the division of substances, right? So how can we define element? It is something in which all the atoms are alike. All the atoms have same atomic number, in which all the atoms have same characteristics, like the piece of gold, like the piece of silver, like the piece of carbon, like the piece of aluminum. All of these contain only one kind of atom, which is called such substances element. Right? You can see the definition on the screen. That's it. Okay. Okay. Symbols. Nickname of an element. The shorthand abbreviation of the chemical name of an element. Hydrogen. Hydrogen. H-Y-D-R-O-G-E-N. We simply write it with H. So H is called the symbol of hydrogen. Oxygen. O is the symbol. Nitrogen, N is the symbol. So what are the three different ways? In the first column, you can see on the screen that we choose the first letter for the symbols of element. As you can see on the screen, H for hydrogen, C for carbon, S for sulfur, O for oxygen, N for nitrogen, F for fluorine, and so on. This is one way. In the first way, we choose the first letter of the chemical name of an element. Clear? Now let's suppose we have different elements, like suppose we have magnesium Like suppose we have manganese or we have molybdenum. All of these are starting with M. So if we choose the first word M, it will create confusion. So what is the second way of assigning symbols? Not only use the first letter, but also you write another one. So what is the symbol of magnesium? Mg. Manganese, Mn. Molybdenum, Mb. So what is the next rule? That beside first letter, another letter could be used. As you can see on the screen also, that chlorine, cobalt, chromium, calcium or calcium, cesium, all are starting with C. So to avoid confusion, we write the second or third letter. Chlorine Cl, cobalt Co, chromium Cr, calcium Ca, cesium Cs. Okay? First way, choose the first letter. Second way of assigning symbols, choose the first letter plus second or third letter. Clear? Third way. Okay. Iron. What is the symbol of iron? The symbol of iron is Fe. Why? There is no F. There is no E in iron. It means there is something different. Why? Because Fe is chosen from its Latin or Greek name, Latin name, ferrum. So iron, its symbol is Fe. Why? Because its actual name is taken from Latin or Greek. So Fe, ferrum. Next is sodium. I think most of you know the symbol of sodium is Na. Why? Because the actual name of sodium is natrium. Right? Potassium, K. Why? Kalium. Silver, Ag. Why? Because its actual name is argentum. That is why we write Ag. And W for tungsten, because its name is wolfram. Hg, hydrogyrum. It is for mercury, which is used in thermometers. Which is used in thermometer. Wait for a minute. Okay, let's proceed further. Initially, Daltons used different kinds of symbols, not alphabetical symbol. Cross means none of your business, just for info. All the elements are arranged in a table that we call it what? The periodic table. Different kinds of periodic tables are there. So what is periodic table? It's an arrangement of elements. It shows arrangement of elements, all the elements. How many elements in all? 118 elements in all. Each and every thing of universe is made up of such kind of elements. We have discovered and prepared up till now 118. Out of 118, we'll study afterwards in detail. 92 are natural, the rest are prepared in the lab by man. We call this table element, periodic table. You remember molecule. Molecule. When an atom combines with another atom, molecule is formed. So what is molecule? Molecule means, what is molecule? Combination of atoms, 2 or more atoms. Like oxygen, O2. It could be same or different. Like an atom of hydrogen combines with an atom of hydrogen to form a molecule of hydrogen. Like an atom of oxygen combines with another atom of oxygen to form a molecule of oxygen, or it could be ozone, right? Same. It could be different, like hydrogen plus oxygen can combine to form water. So this is molecule, this is molecule, this is molecule. What is the difference? Only one kind of atom. We call them homonuclear. This is called heteronuclear. Hetero means comprises of different kind of atoms. Heteronuclear. Homo means comprises of same kind of, all of these are molecules. Then what is the difference? Same kind of atoms. That is why it is called homonuclear. This is called heteronuclear. Carbon dioxide, heteronuclear. Sulfuric acid, heteronuclear. Ozone, what do you call it? Is homo or hetero? Correct, it's homonuclear. P4, phosphorus, homonuclear. S8, homonuclear. So homoatomic molecules comprises of same, and heteroatomic molecule comprises of different kinds of atoms. Right? Note down the questions if you have any. Told you about mixture. Now there are two kinds of mixture in which we can differentiate. Think tea. It's a mixture. It contains milk, water, sugar, right? But we cannot differentiate all of these things. Such mixture are called homogeneous mixture. Like whereas sand in water is called hetero because we can differentiate where the sand is and where the water is. Blood is homogeneous. Air is homogeneous mixture. Right? So there are two kinds of mixture, homogeneous mixture and heterogeneous mixture. Remember, sir, how many minutes are left, sir? Do you have any idea? Just tell me how many minutes are left. How many minutes are left? 5. There are two types of changes, permanent changes and temporary changes. Conversion of milk into curd, chemical, permanent. Burning of paper, permanent. Okay? We are growing from a little kid to bigger one, permanent change. These are called chemical changes. Can't be reversed back by ordinary methods. On the other hand, physical changes, temporary changes. These are not actually the reactions, but just the state changes. For example, if you cool down water, it will convert into solid. So what is the change here? Liquid changes into solid. If you heat water, it will convert into gas, state changes. So these are called state changes, physical changes, right? And these are temporary changes. Next class, it would be the first regular topic of your textbook, different periods of chemistry development. Means we'll, on Friday, we'll start the first topic of your book, a few things. All of these things are available, as you can see here on the screen. My email addresses you can see. You can see today's recording of the lecture on YouTube channel. The name of the channel is Chemistry, Chemist Majid Siddiqui, right? And one more thing, I would like that all of you should be together in a single class so that I can give you assignment and collect those assignments there. That's why you should make Gmail addresses so that I can include in your in Google Classroom. Correct? After 5 seconds, I will change the slide. That's it. YouTube channel. Okay, until the time is over. Feedback assignment. Just take a picture shot, try to do it,